Hey everybody, I wanted to spend a little bit of time going over question 14.71 in Brown-Lemay-Burston. And so this question is going to talk a little bit about mechanism and kind of apply some of the concepts that we have with that. So let's get started. I have transferred that question over to my notebook, and then we will work on it from here, if I can say that correctly. We will work on it. Okay. Now again, if you're going to do videos if you're going to use videos like this, the thing I would do is I would look at the question, pause the video, and then I would try it, and then use my video as kind of the answer key and check your answers. Okay, so let's go over. It says write a balanced equation for the overall reaction. So for part A, what we have to do is take those two reactions and then add them up. Okay, so let's do that. I'll write them down. And now that we've written them down, we can add them up just like we were adding in math class two equations. Okay, so we combine like terms and cancel out things that are on opposite sides. So when we do that, we have HI and HI, and then we have 2I. We can combine these into two, and combine this into 2. So we end up with, let me pick a color here, H2 plus 2 ICl. Did I say ICI earlier? I meant ICl. Plus I2 plus 2 HCl. So this is the overall, this guy is the overall reaction. Okay, and it's balanced, everything works out. And then it says identify the intermediates, or if there are any intermediates in this reaction. So an intermediate is something that is made in one step but is then consumed in another step. So it's the product in one of the steps and then is consumed. That way it's not part of the overall reaction, but is part of the steps that lead to the final answer. So if we look here for part B, okay, I'll put part B over here, we do have HI on this side, and then it gets canceled out over here. And so that's how you can tell if it's an intermediate. Okay, so the intermediate, there's only one, and that's HI. Okay. And then part C says if the first step is slow and the second step is fast, what rate law do you expect? Okay. So remember, the rate law, the speed of the reaction, is dependent on the slowest step in the reaction. Okay, so that is a confirmation of what we already know. Here is that that C is the slow step, and so we can use that to determine the rate law. So it's going to be R equals K, and let's see, H2 raised to the, let me make sure that there's no powers or no orders giving. Okay, raised to the first, and then ICl raised to the first. Okay, and so remember, when you have elementary steps, the power is reflecting the coefficient of each of the step. Okay, so this is a 1, and we look at the elementary step, and that's a 1. Okay, so there's question 14.71, and have a great day, everybody.